In this video, we start working on the handout called Transformation of Functions that's posted as a PDF in Canvas, so you can print out your own copy. And so let's get started with these examples. Now, really the goal with transformations is to realize that if we understand a certain group of very simple functions, we can use those simple functions to understand all sorts of other more complicated situations that are related to those simple functions. So let's get started with example 1. And because we're doing some graphing, I want to use graph paper here. And I've copied my problem example onto a separate sheet of graph paper, and I already set things up a little bit here for us to save a little bit of time. And so we're going to graph the function f of x equals x squared and g of x equals x squared plus 2, that function also, and compare. And I think you should be pretty comfortable with these two examples, so I'm going to try to go a little bit quick through this. In fact, we've graphed f of x equals x squared already in this course. Now I'm going to set up a table of values. I'm just going to pretend here like I'm unfamiliar with it, and if I have no idea where to start, I might just pick some x values like -3, -2, -1, 0, 1, 2, and 3, and evaluate the function, right? So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And so I'm going to plot the points that correspond to these values on this grid off to the side. Now I'm going to indicate my scale here on the x-axis. Each square is just 1. I think I can fit things on just fine this way. And on the y-axis, each square is also 1. So I need to plot the point -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And now, of course, there are many, many more points on this graph, and it's really only by having looked at more detail that I know the shape of the graph is a curve. I'd say the curve is not obvious from these few points, but when you fill in more points, you see that we get this nice U-shaped curve. I think we all know is called a parabola. Okay, so I'm just going to write a little f next to that. That's the graph of f. And now let's, so I'm going to slide this up a bit so we can do some calculations with g. So the g values I'll write in red, just so we have a way to compare the two. And again, I'll look at the same x values and plug into the function g. So I'm doing something very similar, squaring, but then I'm adding a constant on the end, right? Adding 2, so I get 9 plus 2 is 11 at -3. At -2, I get 4 plus 2 is 6. -1 squared plus 2 is 3. 0 squared plus 2 is going to be 2. 1 squared plus 2 is going to be 3. 2 squared plus 2 is 4 plus 2 is 6. 3 squared plus 2 is 9 plus 2 is 11. So now I'm going to go back to my graph grid here, and I'll plot the points for g in red. I have -3, 11, it's right there. -2, 6 is going to be here. negative 1, 3, negative 1, 1, 2, 3, and 0, 2. 0, 2 is like a y-intercept. 1, 3, 2, 6, and 3, 11. And that should be enough for me to be able to make you guys know that this is also going to be a U-shaped kind of graph. And it has actually the exact same shape as F. It's just in a slightly position. So let's label that G. And so what do we see here? We see that we could get the graph of G from the graph of F just by shifting the F graph up 2 units at each point. Make each point 2 units higher. So let's just sum that up in words. Shift the graph of F up 2 units to get the graph of G. And that sort of summarizes our example 1. I don't have the whole table of G on the screen, but I think we see the point here. Okay, so let's look at example 2 now. A couple other functions that we're going to work with, and kind of a similar sort of situation, right? We're working with the absolute value of x, and also the function g is the absolute value of x minus 4. And so let's go ahead and plot some points. So I'm just going to try negative 3 through 3 again. For the absolute value function, when you take the absolute value of a negative, you get a positive. So the absolute value of negative 3 is 3, of negative 2 is 2, of negative 1 is 1, absolute value of 0 is 0, and the absolute value of a positive is just positive. It just leaves it as a positive. The output of absolute value is always positive. And so once again, let's label a scale here. And I guess we already graphed the absolute value function also, so this shouldn't be any surprise what we're getting here. This is another kind of graph that lies on or above the x-axis, right? So we have negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And it looks sort of U-shaped again, but actually I'd say it's V-shaped, right? Because the absolute value graph has no curve to it. It's just a point. It's just pieces of 2 straight lines that come together in this V. And there's the graph of F. And now let's do our G calculations, okay? And same values. And I bet you can all see exactly what's going on here. So absolute value of negative 3 is 3, but then I got to subtract 4, so 3 minus 4 is going to be negative 1 in the end. Absolute value of negative 2 minus 4. I get 2 minus 4 is negative 2. So only the number inside the absolute value is made positive, right? So I get 1 minus 4 is negative 3. Absolute value of 0 minus 4 is negative 4. Absolute value of 1 minus 4 is negative 3. Absolute value of 2 minus 4 is negative 2. Absolute value of 3 minus 4 is negative 1. Seems like we're getting a lot of examples here of y-axis symmetry, by the way, something we talked about at the very beginning of the course. So far, I think all 4 functions have y-axis symmetry. So I'll plot the points for g. -3, -1 is here. -2, -2, -1, -3, -1, -3, 0, -4, 1, -3, 2, -2, 3, -1. And I think you're probably convinced, without me plotting more points, that we're getting another V shape in a slightly different position. So there's our graph of G. And how is the graph of F and G related? Well, it looks like you shift the graph of F downward, right? So shift the graph of F down vertically 4 units to get the graph of G. The point is we shouldn't really have to start from scratch to get the graph of G. We should be able to just look at this and say, take the absolute value function. The -4 is an indication of shifting the graph down 4. Just like with example 1, the +2 was an indication of taking the squaring function and shifting it up 2 units. So in the next video, we'll do some exercises with this idea.